All right, so another concept in this chapter is that of power. You're probably somewhat familiar with power because you can go get light bulbs. For example, a 60-watt light bulb. The units of watts are joules per second. So joules, we know, is energy, and seconds is time. The concept of power is the rate at which work is done. Meaning, how fast is energy transformed from one form to another? In the case of a light bulb, it is converting electrical energy into light and heat if we're talking a typical light bulb. So power, technically it's the derivative of work with respect to time, but we can just simplify it in general to think of it as work or even just energy per time. The energy put into a system, energy taken out of a system, the energy usage per time is what we're looking at. Now, work, remember, if the force is constant, work can be written as force dotted with displacement. Well, displacement over time would be an average velocity. So you will see power written also as force dotted with velocity, but make sure you're looking at the average velocity specifically. And then the force needs to be constant. So whatever that constant force that's being applied that you are trying to look at. So the dot product is there for the same reason it was in the work equation. The force, it's only the component of the force that is parallel to the motion that is doing work. So therefore, it's only that component of force that is contributing to the power. So power is how fast energy is transformed from one form to another. So another silly example, my car versus my lawnmower. Both of them require gasoline. But of course, my car requires a lot more gasoline than the lawnmower because it's doing a lot more work. It has a lot more functions, essentially, that it's doing. It's not only moving, but it also has air conditioning and the radio. It's also going to move much faster, which means a lot more kinetic energy. Not only faster, but it's more massive. So, silly example, but it's still the same concept. So, SI units for power. I was getting confused because it is watts, which we use a W. The W after the number, so my example above was a 60-watt light bulb. The W after the number stands for watts, which means joule per second. W as the start of an equation or representing as a variable means work as opposed to watts. Another measurement of power that you might have seen before is horsepower. This is abbreviated HP. There's approximately 746 watts in 1 horsepower. So just to give you another idea of units. We'll do a couple example problems. Excuse me.